Hi, everybody. Thank you for tuning in today to listen to me talk on in-situ remediation with colloidal activated carbon and how we as REGENESIS have deployed this colloidal activated carbon technology called plume stop to reduce the environmental risk that PFAS poses to groundwater. So as part of this presentation, what I will do is I will talk you through REGENESIS, kind of a bit of an introduction as to what we do and how we work. And then I'll introduce the technology plume stop, this liquid or colloidal activated carbon that can be injected into the subsurface to effectively remove the PFAS from groundwater. I'll also talk a little bit about PFAS, where it can be found and what makes it such a difficult contaminant to remediate. And finally, we will wrap up with a case study. It is the first site where we used plume stop to remediate PFAS. It's a site in Canada. But what I will add is that we have done this across 4 sites here in Europe. We've done 2 in the UK, both of which are airports, and 2 across Sweden, where there was a point source of PFAS contamination. So first of all, just a bit about REGENESIS. What we do is we specialize in the research, development, commercialization, and implementation of injectable substrates to remediate contaminated groundwater. So our focus is very much on groundwater. So we develop these technologies that can be injected into the ground to clean up groundwater. We've been doing this for a long time, for 27 years. We were first established in 1994. And before REGENESIS, nobody had any proprietary reagents that you would inject into the ground to clean up contaminated groundwater. We were the first company to do this. To date, we've done some 26,000 projects worldwide, well over 4,000 projects across Europe. We have a significant European presence. I manage the UK and Scandinavia. I'm based in the UK. Marcello Carboni would be the district manager for Switzerland and Austria and Germany. And we also have district managers across the Mediterranean and for Benelux and France as well. So really, we're a global company and we absolutely have a very established presence here in Europe. So to the meat of it then, what is PFAS? So PFAS stands for per and polyfluoroalkyl substances. And these were considered an emerging contaminant maybe 4 or 5 years ago. I'd argue that they've very much emerged now, particularly here in the European space and North America and Australia as well. And these are contaminants that are found pretty much everywhere. They're fairly ubiquitous in the environment. PFAS, these substances, they've been picked up in polar bear blood, and they're often found in groundwater, which is the focus of the talk today. So these compounds, they are moderately toxic at quite low levels. So they are acutely toxic to marine life, where you have greater than 1 milligram per liter of PFOS and PFOA in the subsurface. So these are other types of PFAS constituents. And as a contaminant and as a chemical, they're very stable and they're very mobile in the environment. So they'll transport very long distances. So it's not unusual for you to be dealing with a PFAS plume that could be a couple of kilometers long. So they're very mobile in an aquifer. They also bioaccumulate as well because they're so stable. So they will bioaccumulate up food chains. So you spill PFAS into the environment, the grass takes it up, a cow eats the grass, we have PFAS inside us. And this is because they are incredibly persistent. So from a remediation point of view, at the moment, they appear to be abiotic, so they don't degrade through natural attenuation. So microbes in the subsurface have a hard time breaking them down. They're resistant to in-situ chemical oxidation. So injecting an oxidant into the subsurface is going to be very difficult to degrade these contaminants. They're thermally resistant. Our understanding of this is evolving. But you do have to heat the ground up to quite high levels to remove PFAS from the groundwater in situ. And they don't degrade abiotically either. So they don't just break down through exposure to UV rays, for example. So they're very persistent. They're also quite ubiquitous, or they were in in consumer products. So, as a point source, often these things are found in firefighting training areas, and indeed that's where my experience comes from, is remediating airport sites where there was a fire training area, and they were spraying firefighting foams, and these firefighting foams had PFAS constituents within them. But that's not just where they've used. They've been used in metal plating, so as non-stick substances, used in textiles as a waterproofer, in the electronics and photographic industries, as part of paper coatings. So sort of fast food wrappers would be coated in PFAS so that the grease doesn't soak through. Used in paints and hydraulic fluids. As I say, they're also found in a lot of consumer products. So in waterproofing reagents, you'll notice a lot of brands now say that their products are PFC free. So that is fluorohydrocarbon free. And this is because historically, some waterproofing reagents would have had these PFAS or PFOA compounds in them. Same with cookware, for example. As I said, PFAS is a term for a bunch of different contaminants. PFOA was often used as a non-stick surface, and we would actually be, cooking with these substances. So they're found everywhere. They're found in, as I say, polar bear blood. They're found in remote places because these things are so persistent in the environment, and they transport very long distances. So what we've been doing in REGENESIS is we've been utilizing a colloidal activated carbon product we have called plumes, and injecting this into the subsurface to take these PFAS compounds out of the groundwater and effectively stick them on the carbon and to stabilize them for a long period of time. So what PlumeStop is, this is a patented technology that REGENESIS has developed. It's a liquid activated carbon, or a colloidal activated carbon. What we've done is we've finely milled granular activated carbon down to 1 to 2 microns. So that's the size of a bacterium or the size of a pore throat. And we've coated it in a dispersion agent so it moves and behaves like a colloid. So blood is a colloid, wine is a colloid. It flows very freely in the aquifer surface. And what happens is when you have PlumeStop and you inject it into the subsurface, you see that it moves very freely through the soil, and it coats the soil with a layer of activated carbon. So this is a microscopic image. The scale bar there is 50 microns across. This is a shot of some sand grains before PlumeStop has been applied. So these sand grains, very flat, not a lot of absorption sites. Afterwards, once the PlumeStop has been injected, this coats the sand grains, greatly increasing their surface area and their absorption capacity. So you're able to pull the PFAS out of the groundwater, stick it onto the activated carbon, and effectively stabilize it in situ. To get this stuff in the ground, we would recommend using direct push injection. This is a very simple technique. All you do is you hammer a hollow stem rod into the ground. On the end of that rod is an injection tip with a non-return valve. And then you inject your PlumeStop across your aquifer, targeting your impacted horizon. So we've been doing this on a number of sites. This slide is a little bit outdated. To date, we have deployed PlumeStop probably on closer to 24 sites worldwide. As I said, we've now done 4 across Northern Europe, primarily in Sweden and in the UK. And we've done further additional sites across North America as well. We have additional sites scheduled. So we have 4 sites that should be going ahead within the next couple of financial quarters. But crucially, we're also involved in many more sites across North America, Europe, Australia, and the Middle East, looking at ways that PlumeStop can be deployed into the subsurface to manage that environmental risk. So to date, we've been involved in about 114 sites worldwide. What we've been doing is essentially injecting a PlumeStop barrier across the down gradient edge of a site. So effectively halting that off-site migration of contamination. And we as REGENESIS will often guarantee this barrier. So we'll offer a warranty or a guarantee for, say, 10 years, effectively assuming that liability from that PFAS release. So we will warranty our solutions. And the installation of this plume stop barrier effectively eliminates the environmental risk that PFAS poses to the aquifer and then the wider environment. So if we pause for a second and we define what environmental risk is. So environmental risk is the hazard. In this case, the hazard is PFAS, and the exposure is the PFAS migrating through the subsurface, hitting the groundwater and flowing off-site. So if we can remove the PFAS from the groundwater, stick it, absorb it onto this colloidal activated carbon, we've effectively removed that exposure and eliminated the environmental risk. So I'm just going to quickly talk you through one case study. This is the first site that we did. This is in a site in Ontario in Canada. Here, the initial remediation driver was pollution of groundwater because of petroleum hydrocarbons. This site was a furniture manufacturing facility. It also had a former firefighting training area on it. The consultant did further investigation, and considering its history, so as I said, these PFAS compounds have been used in textiles as well as firefighting foams. They looked for PFAS, so they were primarily concentrating on PFOS and PFOA, and they found significant concentrations. So they had up to 3,400 nanograms per litre. So to address this, what they did is they injected plume stop across the plume, effectively stabilizing the PFOS and PFOA plume, and also absorbing the petroleum hydrocarbons that would then be degraded through natural attenuation. So this site was done some probably close to 5 years now ago, and post injection of plume stop, concentrations of PFAS dropped to below detection limit. So in this case, below 20 nanograms per litre, or 20 parts per trillion. This was one of the first sites where this was, well, it was the first site where this technology was deployed. There was a lot of third-party interest. One of those third parties was a consultancy called Poor Water Solutions, and they were looking at the breakthrough time, because we're not destroying the contamination, we are stabilizing it in the subsurface. And what they were keen on doing was to establish at what point would you start to see breakthrough of this PFAS. So what they did is they looked at modeling the treatment that we had deployed to see at what point they would see breakthrough post-injection. So they did this based on a series of Freundlich absorption isotherms. Initially, they looked at the in-house absorption isotherm we use for plume stop, and based on their modeling, it would successfully absorb that contaminant mass for over 100 years. We essentially broke the model. If they assumed that REGENESIS was an order of magnitude out, we would still get 86 years worth of treatment before we saw any sort of breakthrough. And if we were even further out, we would still deliver 29 years of treatment following a single injection of plume stop. Now, this is all written up in and published in various third-party papers. What I would say is, if you are interested in PFAS, please do go and visit our website. Under our resources section, you can see PFAS resources. That will take you to a series of third-party articles, lots of animations and videos that are all free to download. And we have some 12 hours of webinars talking about PFAS, not just REGENESIS talking about PFAS, but also world-recognized experts, regulators, lawyers, consultants, contractors, liability holders. It's all there. And if after reviewing this information you'd like to reach out, there is a contact us section. If you click on that, you can reach out directly to me or your local REGENESIS representative. As I say, we have a pretty good network based right across Europe. Some of the benefits of using plume stop is that it is a proven technology. It's been used on over 14 sites to date across the world, including, and we have now over 4 years of validation data. 3 third-party academic papers have been written on this technology, and it is a recognized remediation technique for PFAS by the ITRC in the US. It's effective, you get rapid and long-term protection, you can quickly see if this product is working, and it is available. This isn't a research and development technology, this is a patented technology that is commercially available and is being rolled out across multiple sites across the world, including here in Europe. So that's everything from me. These are my contact details, and please feel free to connect with me on LinkedIn using this QR code. If you have any questions, I'll be pleased to answer them at the end of the session. Otherwise, if we don't get around to your question, as I say, please do reach out to me. More than happy to talk through any requirements that you have for your site. So thank you for listening, and I welcome some questions. Thank you very much.